Yeah, okay, Bharat. So thank you so much. So just give me a second. We will start. So why I couldn't find you guys in yesterday's class? Is there any issue? Network issue? Okay, no problem. Good afternoon, Pallavi. So very good afternoon once again to all of you guys. So let's go ahead with the today's session. So we are dealing with the alcohols, phenols and ethers. Okay. So yesterday, we have covered the preparation of haloarenes. Okay, there were 4 preparations under that. And after that, I have discussed about the physical properties and some of the chemical properties of haloalkanes and haloalkenes. Okay, we did not enter into the haloarenes. Some of the physical properties and some chemical properties of uh, this alcohols, phenols and ethers. Got it? It is not about haloarenes. It was about the alcohols, phenols, and ethers. Sorry for that. So today we are going to see some more chemical properties of alcohols, phenols, and ethers. Okay. Okay. So the learning objectives for today's session are, so we are going to see the reaction with HX and PX3, then dehydration of alcohols and oxidation of alcohols. Okay, so we will try to cover this in today's class, and if time permits, we will go beyond this. Got it? So moving ahead with the reactions with HX and PX3. So first of all, we will study about the reaction with hydrogen halides. Okay, that is the reaction with HX. The reaction of which compound? Alcohols. Okay, it is not haloarine. I have said by mistake, sorry for that. So we are studying the reactions of chemical properties of alcohols. Okay. So we all know that the general formula for alcohol is ROH. And if ROH is treated with HX, and if we try to heat this, so what they will do, they will eliminate the water and there will be the formation of RX. Okay. So H2O will be eliminated from both the compounds and we will get RX as the main product. Okay. Alkyl halide we will get and water is the byproduct. And here we use a catalyst called anhydrous zinc chloride. Got it? And that anhydrous zinc chloride is used to eliminate the water, remove the water from the compound. Okay. So now let me take one example. So which alcohol? So I will take ethanol. So you all know the formula for ethanol is CH3CH2OH, right? And the hydrogen halide that I have taken is HCl. So what will be the product from this reaction after elimination of this water? So we will get CH3CH2Cl, which is called as ethyl chloride and H2O. Okay. So here the alcohol which I have taken is the primary alcohol. The alcohol which I have taken is the primary alcohol. Okay. Very good, Sneha. It is ethyl chloride. So we do have secondary alcohol, tertiary alcohols and primary alcohol, right? So among these three, the order of reactivity of alcohol will be tertiary more reactive than secondary and secondary is more reactive than primary. Okay. So tertiary alcohols are more reactive towards the reaction with HX. Got it? So very simple reaction which you can do it easily on your own. Okay. So you don't have to struggle much to find out the product. So it is very easy. Okay. So now let's go ahead with one more reaction, and the name of that reaction is Lucas test reactions. Okay, Lucas test. So basically this test is used to distinguish the primary, secondary and tertiary alcohols. Okay. So let me take all the three types of alcohols. And here, all these alcohols, the first one is primary alcohol, and the second is the secondary alcohol, third one is the tertiary alcohol. Okay, you can see that CH2OH, CHOH, and here COH. So all the three types of alcohols are colorless. Okay, all the three are colorless. Got it? If I try to make all these alcohols to react with the Lucas reagent, so we should know what is a Lucas reagent, right? So it is zinc chloride and concentrated HCl. So if I try to make them react with zinc chloride and concentrated HCl, the tertiary alcohol will form the compound immediately, and the turbidity will also form because of that immediately. So what is meant by turbidity? In the container or in the beaker, some kind of solid particles will be settled down at the bottom, okay, or kind of mixed kind of solutions will be there, okay. So colloidal kind of solution will be there. So that is called as turbidity. So that turbidity will form immediately. So if you are getting the turbidity immediately, then you should come to the conclusion that the alcohol which you have taken is the tertiary alcohol. Because we are doing the test, right? So we do not know which alcohol is present inside the container in the laboratory. Okay. So to find out the alcohol, if you are getting the turbidity immediately, then you can say that the alcohol which you are having in your hand is the tertiary alcohol. Okay. And if the turbidity is formed within 5 minutes, if it is formed within 5 minutes, then it is secondary alcohol. Okay. And if there is no turbidity, okay, or if you are getting the turbidity on heating means, then you can come to the conclusion that the alcohol is the primary alcohol. Okay. So this is how we find out the different types of alcohol using the Lucas test. This is very, very important. The Lucas reagent is very, very important. Okay. Zinc chloride and concentrated HCl. So basically this OH will be replaced by chlorine in the product. Okay. That is the reaction. And test means there should be some indication, right? So if you are looking in our eyes, we should be able to distinguish something, some color change or turbidity formation or using precipitation. So such kind of things should be there. And here turbidity is forming. Okay. If there is no turbidity, it is primary. If turbidity forms after some time, it is secondary. If it forms immediately, then it is tertiary. That's all. Okay. Primary, secondary, and tertiary. Got it? So the Lucas reagent is very important. You should know which alcohol will give the turbidity immediately and the other things, etc. Okay. So here the OH is replaced by Cl. So that's why it is coming under the reaction with HX. Okay. Here we are using HX, right? So that's why it is coming under this HX reaction. Got it? So now let me go ahead with the reaction with phosphorus trihalide. So what is meant by phosphorus trihalide? PX3, phosphorus trihalide. So what will happen if an alcohol is treated with phosphorus trihalide and on heating? They will form the alkyl halide and phosphoric acid. So we have already studied this reaction in haloalkane preparation. So do you guys remember that? In haloalkane preparation, we have seen this, right? Do you remember? Have you studied the preparations of haloalkanes? So the preparation of haloalkane from alcohol. Under that topic, we have discussed this, and this was the first preparation also. Okay. So here what is happening? The OH is getting replaced by the halogen. OH is getting replaced by the halogen X. So if I have to take one example, methyl alcohol on treatment with PCl3, we will get. Can you give me the product formula? So what will be the product from this reaction? Can anyone give me the name of the product, the main product, or the formula of the main product? It's very easy, right? Methyl alcohol plus phosphorus trichloride gives dash plus H3PO3. So somebody fill the dash. Is it RCH? Is it RCH3, my dear? No. H3PO3 is okay, but it is not RCH3. Just think once again. R group is the CH3 group here. Yeah, very good. It is CH3Cl and H3PO3. Methyl chloride is formed. Methyl chloride is formed. Okay. So this is the reaction with phosphorus trihalide. Then coming to the next reaction, do you guys have any doubt in the reaction with HX and in the reaction with the PX3? Any doubt in Lucas test? Everything clear? Shall we go ahead with the next reaction? Okay. So what about others? Only Sneha is giving me the reply. Yeah, very good, Priyanka. Okay. Thank you so much. So we will go ahead with the next reaction, and it is called as dehydration of alcohols. Okay. Dehydration of alcohols. So what is meant by dehydration? Can anyone give me the meaning for dehydration? What is called as dehydration? Yeah, dehydration means it is removal of water molecule, right? So we are going to take an alcohol and we are going to remove the water molecule from the alcohol. Got it? So I have taken an alcohol and the name of the alcohol is ethanol. Okay, and H2O is going to get removed. Okay, and it is going to give me the product. Okay, the product is an alkene. So such like that the water will not come out from the alcohol, right? We have to use some dehydrating agents to remove the H2O. So the dehydrating agents are concentrated sulfuric acid, concentrated phosphoric acid, anhydrous zinc chloride, and aluminium oxide. Okay, you don't have to use all the 4 reagents at the same time. You can use any one among these. Okay, all the 4 are used to remove the water from the alcohol. Okay, clear for all of you? So all the 4 are the examples for dehydrating agents. So use any one and remove the water from the alcohol to get an alkene. Got it? So now we will go with some more reactions of this dehydration. So I have taken ethanol. I have taken ethanol and I am going to use the sulfuric acid and I am going to heat this. Temperature is 443 Kelvin. Okay, so what I will get? I will get ethene and water, right? So if I take some other alcohol like propene 2-ol, it is not propene 2-ol, it is propane 2-ol. Okay. So here, if I use 85% of H3PO4 and if I heat this to 440 Kelvin, I will get propene and water. I will get propene and water. Okay, so here the acid concentration might be 100%, okay, or 99.9. Here 85% is enough to remove the water molecule from the propane 2-ol. Okay, and if I take the tertiary alcohol, this is tertiary alcohol, right? So in case of ethanol, it is CH3CH2OH. So this is primary alcohol. Ethanol is a primary alcohol. And what about the second compound? It is CHOH. It is a secondary alcohol. And what about this? COH. It is a tertiary alcohol. So if I take a tertiary alcohol, that is 2-methyl propan 2-ol, just 20% of H3PO4 is enough. Dehydrating agent is enough, and at low temperature also it is capable of producing the alkene. Okay, and water is eliminated. So what is the ease of dehydration? Tertiary alcohols can easily give out the water molecule than secondary alcohol than a primary alcohol. Okay, so very less concentrated dehydrating agents are enough to eliminate or remove the water from the alcohol for tertiary case. So is it clear to all of you? Tertiary is more reactive than secondary. Secondary is more reactive than primary for dehydration reaction. Okay? Any doubt? Okay, fine. So now we will go for the next type of reaction. Okay? The third type of reaction, chemical reaction, which is oxidation of alcohol. So what is meant by oxidation? It is addition of oxygen or removal of hydrogen, right? So what will happen if we oxidize the alcohol? So I am taking one alcohol. So this alcohol is called as methanol. If I try to oxidize this methanol, what will I get? So the two hydrogens among the four will come out. That is, removal of hydrogen is happening here and it leads to the product called aldehyde. Okay. So basically, the oxidation of alcohol involves the cleavage of an OH bond. The cleavage of an OH bond and the cleavage of an CH bond. Okay, both the bonds are getting cleaved and there is a formation of C double bond O bond. Okay, so cleavage of OH, cleavage of CH and formation of C double bond O. So oxidation involves these three cases and it is also called as dehydrogenation reaction. Oxidation of alcohol is also called as dehydrogenation reaction because we are removing two hydrogens, right, by cleaving the bonds. So removal of hydrogen is called as dehydrogenation. So that's why this reaction is called as dehydrogenation reaction. Okay. So now let me go ahead with this concept. So let's do the reaction with primary, secondary and tertiary. So all the three types of alcohols, oxidation of primary alcohol, oxidation of secondary alcohol, oxidation of tertiary alcohol. All the three types of alcohols can be oxidized. Okay. So let us see one by one. Let me start with the oxidation of primary alcohol. The very best reagent to oxidize the primary alcohol are going to, I'm going to list out those reagents. If a primary alcohol is getting oxidized, it will give aldehyde. Okay. RCH2OH is called as primary alcohol. And if I oxidize this, I will get an aldehyde. So CHO is an aldehyde, right? So it will give an aldehyde. The reagent is, the best reagent for this oxidation is PCC. PCC is called as pyridinium chlorochromate. Pyridinium chlorochromate. And also I can say that this PCC is a mild oxidizing agent. It is a mild oxidizing agent. So why I am calling this as mild oxidizing agent? Because the reaction stops up to the formation of aldehyde. Okay. Aldehyde can be further oxidized. Okay. Aldehyde can also be further oxidized and they will lead to the formation of carboxylic acid. Okay. But PCC is not allowing the alcohol to reach the point of carboxylic acid. It just stops with the aldehyde. Okay. So if some alcohol is getting stopped at the stage of the formation of aldehyde itself means, then those reagents are called as mild oxidizing agents. Okay, so then when will I get the carboxylic acid? I will get the carboxylic acid if I am using the strong oxidizing agents. Okay, I will give you that list. Okay, first of all, you write PCC under the mild oxidizing agent list. Mild oxidation means the primary alcohol will give aldehyde. Okay, it will not get oxidized beyond the aldehyde. Okay. Now, what will happen if I oxidize a secondary alcohol? Secondary means CHOH component will be there. And here, OH bond and CH bond will be broken down. And there will be the formation of C double bond O. There will be the formation of C double bond O. Very good, Priyanka. So, it is ketone. Okay, secondary alcohol on oxidation will give ketone. And the oxidizing agents for this transformation is CrO3, chromium trioxide in anhydrous medium, or copper at 573 Kelvin. Okay, so these two reagents can help the secondary alcohol to get converted to ketone. Okay, I will take one example. Let me take the R group and R dash group as CH3. So by taking so, I will get this alcohol, and if I use any one of these two reagent, I will get the product, right? Can anyone give me the name of the product or the formula of the product that I will get from the oxidation of this particular alcohol? R and R dash are CH3. And you have to cleave two bonds, OH bond and CH bond, and you have to form a new C double bond O. Very good, Sneha. It is propanone, okay, which is a ketone. So since we have 3 carbons, it is called as propanone. Okay. So, or acetone. Acetone is the common name and propanone is the IUPAC name. Okay. So this is all about the oxidation of secondary alcohol. So now what will happen if I oxidize the tertiary alcohol? So basically, they do not undergo oxidation. They do not undergo oxidation if copper is used. Okay. So if copper is used, if copper at 573 Kelvin is used, they will not get oxidized. Instead, they will get dehydrated. Means water molecule will be coming out from the tertiary alcohol. And they will lead to the formation of an alkene. Okay, so this is one side. And instead of copper, if I use acidified KMnO4, carbon-carbon bond will be broken down. If I use KMnO4, carbon-carbon bond will be broken down and they will lead to some other product. They will lead to some other product. Now we will see these two reactions in the next slide. Okay. So let me take the acidified KMnO4 reaction first. So when acidified KMnO4 is used, what will happen? The carbon-carbon bond will break. Okay. So let me take a tertiary alcohol. So this is the example for tertiary alcohol where I have only the COH linkage. Okay. And all the other parts, all the other 3 parts are alkyl groups. Okay. Tertiary alcohol. And if this particular alcohol is treated with acidified KMnO4, there will be the breakage of CC bond. So which carbon-carbon bond? This one. Okay, this carbon-carbon bond will get cleaved and we will get CH3, C double bond O, CH3. Okay, and OH bond will also be cleaved and we will get CH3, C double bond O, CH3. Ketone. And this 2 carbon system is coming out, right? After cleaving this, the 2 carbon, CH3, CH2 is coming out, right? So those 2 carbon will form a new compound that will also get oxidized. The 2 carbon containing part will form a 2 carbon containing carboxylic acid. Okay. So what we are getting? We are getting one ketone and we are getting a carboxylic acid. Okay. So if the tertiary alcohol is treated with acidified KMnO4, it leads to the formation of ketone and a carboxylic acid depending upon the reactant which we are taking. Okay. So not in all the cases, depending upon the reactant. Got it? And what will happen if the tertiary alcohols are treated with copper at 573 Kelvin? This is the second classification, right? And this leads to dehydration. This leads to dehydration. They undergo dehydration in place of dehydrogenation with copper at 573. So take the same tertiary alcohol. Okay, CH3, CH3, CH3. All the 3 alkyl groups are CH3 here. And if it is treated with copper and if it is heated up to 573 Kelvin, it will lead to the formation of an alkene. Okay. So one of the beta hydrogen OH attached carbon is alpha. And the carbon which is attached to it is beta. So all the 3 are beta carbons only. and all the hydrogens which are attached to beta carbons are beta hydrogen. I am going to take this particular carbon and one of the hydrogen which is attached to it. So that will go out. This bond will shift here and the CO bond will be broken down. Okay. So there will be the formation of carbon-carbon double bond, which is an alkene. Okay. So with acidified KMnO4, it undergoes oxidation. With copper at 573 Kelvin, it undergoes dehydration. Okay. So this is all about the three reactions. Okay. Three reactions of alcohols. So let me summarize studied from the today's session. So first of all, we have studied about the reaction with HX and it leads to the formation of alkyl halide with anhydrous zinc chloride. And also we have studied about Lucas test, and this test was used to distinguish primary, secondary and tertiary alcohol. Then reaction with PX3 gave alkyl halide and H3PO3. Okay, for this reaction, the ease of dehydration is tertiary more reactive than secondary and primary. Okay, then the second type of reaction is oxidation of alcohol. If primary alcohol is getting oxidized, they will give aldehyde. Mild oxidizing agent is PCC. Okay, and also some other classifications we have studied under this. So PCC is a mild oxidizing agent. CrO3 is the mild oxidizing agent. Okay, and acidified KMnO4 is the strong oxidizing agent. Acidified KMnO4 is the strong oxidizing agent. Okay, K2Cr2O7 and KMnO4, all these are strong oxidizing agents. All right. So this is all about the reactions of the chemical reactions of alcohols. All right. Do you have any doubts from this? Do you have any doubts from this? No? Okay. So now, next we will jump into the reactions of phenols. And after studying the reactions of phenols, I will go into some important alcohols. Okay. Reactions of phenols is a very, very important topic. Okay. All the reactions under this reactions of phenols are very important. So please listen properly. Okay. So the learning objectives for the reactions of phenols are the electrophilic aromatic substitution reaction, which are actually nitration and halogenation. And later on, Kolb's reaction, Reamer-Tiemann reaction. Okay. So we are going to cover these three basically. And at last, we will study about some commercially important alcohols. All right. So let me go ahead with the electrophilic aromatic substitution reactions of alcohols. Let's study the mechanism first and then we will enter into the reactions. Okay, so you might be knowing about this electrophilic aromatic substitution because in the previous lesson also we have studied, right? Nitration, halogenation, sulfonation, etc., etc. The same thing we are going to do here also. Okay, so since we are studying about the reactions of phenols, I have to take a phenol. What is the formula for phenol? C6H5OH. Okay, now the electrophile will come and get substituted in the ortho position and in the para position. You know why? During the resonance time, only the ortho site and the para site. Ortho means adjacent, para means opposite. Only those two sites will get the negative charge. The negative charge will be delocalized on the ortho and para position. Okay, negative charge means the electron rich site, right? So the electron deficient electrophile will come and get attached to that ortho and para site. Okay, there is no effect on the meta site. So ortho and para sites are the more favorable sites for electrophilic attack. What are electrophiles? Electron deficient compounds are called as electrophiles. Okay, so which is represented by E plus. So E plus will come and substitute one of the ortho position, and the hydrogen will come out from the benzene ring, phenyl ring. Okay, or if it is coming and substituting in the para position, the hydrogen which is attached in the para carbon will be replaced by the electrophile. Okay, so this is the mechanism. Now let's enter into the reactions of this. So the reactions we are going to study in for phenols are nitration and halogenation. We are not going to discuss about the sulfonation, Friedel-Crafts alkylation and Friedel-Crafts acylation. Okay, so those three reactions are not going to be not going to get discussed here in the reactions of phenols. Only two we are going to study. Okay, please concentrate on those two. So let me start with the nitration of phenol. Nitration of phenol. So what we have to do? Take a phenol and add the nitrating mixture. So who's the nitrating mixture? Diluted HNO3. Actually, we use concentrated HNO3. But with the phenol, we are going to do with both HNO3. Both means diluted HNO3 and as well as with concentrated HNO3. Okay. So first I'm going to do the reaction with diluted HNO3 and H2SO4. Okay. So if I use this particular nitrating mixture, the product that I will get is orthonitrophenol and para-nitrophenol. Okay. So if phenol is treated with dilute HNO3, if phenol is treated with dilute HNO3, the product formed are orthonitrophenol and para-nitrophenol. Okay, very important reaction. Please keep this in your mind. Now, why NO2 group is getting substituted? Can anyone tell me why NO2 group? Because it is the electrophile, right? So from the nitrating mixture, the electrophile that we get is NO2 plus. In all the organic chemistry lessons, we get NO2 plus as the electrophile for nitration. Okay. Now, we are going to discuss about the products that we got from the previous reaction, that is orthonitrophenol and para-nitrophenol. In case of orthonitrophenol, there is intramolecular hydrogen bonding formation. So what is meant by intramolecular? If hydrogen bond is formed within the same molecule, if hydrogen bonding is formed within the same molecule, it is called as intramolecular. So let me take the structure of orthonitrophenol, and you see here the oxygen of nitro group, this is the nitro group, NO2, and this is OH. The oxygen of nitro group is forming the bond with the hydrogen of OH. Okay, so this hydrogen bonding is called as intramolecular hydrogen bonding. Okay, this intramolecular hydrogen bonding is weak. It is not a strong bond, it is a weak bond. If it is a weak bond, the molecule is steam volatile in nature. So what is meant by steam volatile? So they will get evaporated so easily. Okay, very less temperature. They will get evaporated at very less temperature. It means the boiling point of the species is very, very low. At very low temperature itself, the compound can get volatile. Okay, so this is about orthonitrophenol. On the other side, if you talk about para-nitrophenol, so there we have intermolecular hydrogen bonding. Intermolecular means between two molecules. The hydrogen bonding between two molecules. So I have to take two para-nitrophenol. This is one molecule and this is the other molecule. The nitro group of one molecule will form the hydrogen bonding with the OH group of the other molecule. Okay, and this is intermolecular between two molecules. Okay, and this molecule, if I try to treat this with some other, they will form and the hydrogen bonding goes on. And this intermolecular hydrogen bonding is strong. Okay, this bonding is strong. Very, very difficult to break. So it requires high amount of energy to be broken down. Okay, so only at very high temperature we can break this bond. Okay, so it is less volatile in nature and it is having the high boiling point thing. Okay. So ortho and para product will be formed within the same container. Okay. Within the same container. And if you want to separate ortho compound and para compound, okay, if you want to separate these two isomers, then you have to use some separating techniques, right? So one among the technique is called as steam distillation. Okay. So using the steam distillation process itself, you can separate these two, because one is having a very low boiling point and the other one is having high boiling point, right? So at a very low temperature, the orthonitrophenol will come first, so that you can separate that orthonitro from the reaction mixture, and then later on only the paranitrophenol will be settled down at the bottom of the container. Okay. So you can use steam distillation to separate the compounds. Got it? So the concepts which I have said for orthonitro and paranitropenols are very important. Okay. So assertion reason type of questions can be asked from this part. Okay. Assertion reasoning type questions will come from this particular part. So you have to be very careful. So do you have any doubts with this nitration of phenol and the informations about the orthonitro and paranitrophenol? Is everything clear for all of you? Bharat, Valmiki, Pallavi, Shreya, Pushpa, Sneha. I have to call each and every one of your names or what? Suraj, Veena, Yashwant, Satyadeva. Do you guys have any doubt in the nitration of phenol with diluted HNO3? With diluted HNO3? Okay. So now let's go ahead with the nitration of phenol with concentrated HNO3. So what happens if phenol is treated with concentrated HNO3? So here we get a tri-substituted product. Tri means 3 NO2 group will come and get substituted in one phenol. Okay. As I have already mentioned, they will come and get substituted in both the ortho position and in the para position. Okay. So we get a tri-substituted product and we have to number this, right? OH attached carbon is numbered 1, 2, 3, 4, 5 and 6. So it is 2, 4, 6 trinitrophenol. Okay, this is the IUPAC name. And the common name of this compound is picric acid. Common name of this compound is picric acid. So this is all about the reaction with concentrated HNO3. This is about the reaction with concentrated HNO3. Okay. So with diluted HNO3, we get ortho and para product. With concentrated HNO3, we get a tri-substituted product. That's all about the nitration of phenol. Then let me enter into the second electrophilic substitution, which is halogenation of phenol. Okay, so we will complete this in today's session, and then we will go for the next class. Okay. So coming to halogenation of phenol, there are two cases. First of all, the halogenation can be done with the solvents of low polarity like CCl4, CHCl3, etc. Okay. If the phenol is treated with such type of reagent, then they will lead to monohalogenated product. Okay, only one halogen will come and get substituted in the phenol. In the other case, if they are treated with solvents of high polarity means like water. In case of water, we get H plus and OH minus, right? So that plus minus separation will be more. So the bond will be more polarized. If such kind of solvents are used for halogenation, then we get the tri-substituted product, like in the previous case. So we get 2,4,6 substituted product. Okay, now let's go for the reaction. So let me start with the solvents of low polarity and let me do the bromination. Okay, so take a phenol And the halogen that I'm going to use here is bromine, and that's why the reaction is called as bromination. In carbon disulfide, carbon disulfide is an example for solvent with low polarity. Carbon will be here and 2 sulfur. Okay, this is a solvent with low polarity and we are heating it. So only one halogen will get substituted, right? So one at ortho position, so orthobromophenol, and the other one will get substituted at para position. So I will get para-bromophenol. So in one compound, only one halogen can be substituted. One at ortho and another one at para. Okay. So instead of this, if I use the solvent with high polarity, so phenol with 3 moles of bromine and with water. This is a solvent with high polarity. So this will lead to the tri-substituted product. 2,4,6 tribromophenol is formed with the elimination of 3HBr. Okay. This is about the bromination. So why Br is coming out as an electrophile? Because we know that from halogenation, the halogen, from halogenation, the halogen will come out as an electrophile. If I am using Cl2, Cl plus will be the electrophile. If I am using Br2, Br plus will be the electrophile. Okay. So that halogen which is coming out as an electrophile is getting substituted in the ortho and para position to give the corresponding products. Okay. So what we have studied today, we have studied some of the chemical reactions of chemical properties of alcohols and alcohols. And there were 3 reactions, okay, in the chemical properties of alcohols. And we have entered into the chemical properties of phenols. And under the chemical properties of phenols, we have covered the 2 reactions. 2 means under one type, we have studied 2 reactions, right? So the type is called as electrophilic substitution. And under this topic, we have discussed nitration and halogenation. Okay. So we are left with 2 more reactions. One is Kolb's reaction and the other one is Riemann-Tiemann reaction. So we will cover that in the next class. Okay. So by the way, I have launched a poll for you guys. So please do give me your answers over there and then get ready for your next class. Okay. Thank you so much for attending the today's session. Do you have any doubts from today's class? So please try to join on time from next class onwards. Okay. Don't delay. Till then, take care. Bye-bye. Thank you. So please do give your feedbacks.